Okay, let's go through this so that we all have the correct information. Please make corrections as we go through this. Okay, if you read the question and you didn't quite understand it and your answer doesn't look like what it's supposed to, go ahead and correct as we go through this. We ended up, I'm not going to hit the chart, by the way. I'm pretty sure most everybody had that correct. I'm going to start with number 3. Now we have all these kittens. These kittens, each one has 7 stripes. Notice how they rewrote the problem now. Kittens were 7 to the 4th power. And now we're multiplying by another 7. How do we write that in exponential form? Alan? 7 to the 5th. What is this in standard form? Remy? 16,807 stripes, right? Stripes. Okay, that's a lot of stripes. Now, if you read what the associative property is, if you looked at the examples, you can see that they're putting parentheses around different numbers. All the associative property really is all about grouping. I just heard somebody say that. You're exactly right. It's just about grouping them differently. It's the exact same problem. It's just grouping. So what they did on 4, they grouped 1 7 together, and then they grouped 4 of them. What's another way we could have grouped them?
3 and 2.
So put 3 7s and then 2 7s. Whoops, that's supposed to be a 7.
That's right.
Okay, Remy.
7 times 7 times 7 times 7. So 4 7s
And then 1. And there's probably one more left.
2 7s and
2.
And then isn't there?
I always make those 2s. That's crazy. Okay. So these are all the ways I could group them. This is going to lead us to the big rule that we're trying to find. Now we want to write them using exponents. How do I write this first one using exponents?
7 to the 3rd power and then 7 to the 2nd power.
Okay. So 7 to the 3rd power, 7 to the 2nd. So basically, how many 7s are there? 7 to the 5th, right?
Yeah.
Okay. How would I write the second one we wrote down?
7 to the 4th.
7 to the 4th.
And 7 to the 1st.
And what do I get?
7 to the 5th.
And my last one would be written
Opposite of the very first one.
7 to the 2nd times 7 to the 3rd equals 7 to the 5th. So really, it didn't matter that I grouped them differently. If you had 3 people at your table and you all made these different groups, would you all have gotten the same answer?
Yes.
Yes. The associative property does not change anything. Okay, if we flip over, this is where the big idea comes from. What patterns did you notice with the exponents? What happened in every single case?
They alternated.
It's not the alternating. Peyton. They go in order.
They're still 7 times 12.
3 and 2, 4 and 1, 2 and the what adds up? The exponents all added up to 5. So any patterns we noticed the exponents all added up to 5.
I don't get the whole 6 part.
Okay. 6 is where it's going to bring it together so that you are going to get this first rule of exponents. And when you walk out the door today, you're going to be like, wow, we actually learned something brand new. Let's look at this one. Instead of 7s, what is the base? Or what are we talking about here? So x is the base on this one. We're talking about x's. How would I rewrite this using exponents?
X to the 2nd and x to the, or actually x cubed and then x squared and then cubed.
Okay? X times x is actually x squared. X times x times x is actually x cubed. Now, how would I simplify this expression? What is it? It's x to the
5th.
How do you know it's x to the 5th?
Because
Because the exponents add up to
The exponents add up to 5. How else do you know that it's going to be x to the 5th?
There's
The same
five
number, so
X's.
you can add the exponents together.
You can add the exponents together, but could I also just count how many x's I have? It takes a little longer, but I could. So to simplify the expression, it's x to the 5th. Now, if we look, I'm going to just
Third.
take one of these and then take this one.
Those are the same.
Are there any similarities?
The exponents.
The exponent. What do I do with the exponents?
Add them
They add
together.
up to 5.
So add
Up to 5.
exponents together. Do you think all problems are going to add up to 5?
No.
No. But what we've learned so far is that I can add the exponents together in either problem. What do you notice about the bases for each problem? You have to have the same base. When I had my first problem, I could add them together because they were all 7s. In the second problem, I could add them together because they were all x's.
Like if it was a 7 to the second and a 6 to the second, you couldn't do it.
Right. Well, what did you say?
Like if it was a 7 to
Yes.
the second power and 6 to
Right.
the second power.
Right.
Why?
We'll go over a problem like that here in just a second. We're going to write a rule now. This is going to be your go-to in case you ever get lost. We're going to write a rule for multiplying terms with exponents that have the same base. And we're going to write it as a complete sentence. So when we do that, we basically rewrite part of the question. So let's write out multiplying terms with exponents that have the same base. What do you do with the exponents?
Add them up.
All we do is add the exponents. And I'm going to underline add 3 times.
So you're going to capitalize it?
When we are multiplying terms with exponents and they have the same base, all we have to do is add the exponents.
So you're going to capitalize the A, D, D.
Let's do several examples, and I'm going to put them in my notes section here just to make sure. Did everybody get that?
No.
Yes.
Yeah, no, I don't.
Basically, you are just rewriting the second piece of the question so we get it in a full, complete sentence, and then we're writing the piece that we just found. Hey guys, we just add the exponents. That's it. Okay? Let's put some notes in here so if you ever do get confused, you can go back. We're going to just call this number 1. I'm going to say, and I'm just going to make this up, b to the 7th times b to the 4th. Could you simplify that?
Yeah.
What is b to the 7th times b to the 4th? How do you know it's b to the 11th? You add the exponents. What happens if you forget the rule? Could you still solve this?
Yes.
Yeah.
What does b to the 7th look like?
7. It's just going to be B. Still going to be B.
How many b's are there?
7.
There's 7 b's. b times b times b times b times b times b times b. What does b to the 4th look like?
B times B times B times B.
So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So even if you forget this rule that you just found, you can still find the answer by writing it out in expanded form. Let's try another one. See if you can get this one. 3 to the 3rd times 3 to the 5th. Notice my base is a number. That's okay. It's still a base.
It's 3 to the 8th.
It is 3 to the 8th. Here I would have 3 3s. Here I would have 5 3s. And if I counted them all up,
It'd be 8.
I would have 8 3s. Now, we are not to this point. It's coming down the road, but I want to show you how this rule still works. I'm going to have a to the 7th times a to the 0.
One
Now,
is
what does
seven.
the rule say? What do you have to do?
7 times the exponent.
You add the exponents.
It should be 8 times 7.
It would just be a to the 7th. What does that mean that a to the 0 has to be then, if it stayed a to the 7th? It kept its same identity. What do you multiply by if it's going to keep the same identity? 1. If I multiply by 0, I would get 0. So this is just a little foreshadowing when we start working on what do those 0 exponents mean. Okay? I'm going to do another one here. Are you guys all taking down these notes? Because this will help you with your homework today. Okay, very good. What happens if I have n to the 3rd times n? What do you think that is?
Just end of the third because there's no exponent.
There's no exponent, but let's look at this. What does n to the 3rd mean?
Wait, no, it would still be a
3 n
point of
times n
one,
times n.
So it's going to
it'd
be
be
n to the
Be
fourth.
because 1n equals n and then 1n.
And then I have to take it times this n. So this n basically has an exponent of what? 1. Does it still work now to do my rule? It's n to the?
Fourth.
Because what do I do with the exponents?
Add them.
I need to add them. And 2 more. Because I know you don't know what these exponents mean, but our rule still works. If I have n to the 7th and I have n to the -3, don't flip out because it's a negative exponent. We will get there so you understand what that is. But our rule still works.
Yeah.
What is my simplified version going to be? Into the 4th. 7 plus a -3 is 4. One more just to test it out. X to the -5th times x to the -2nd.
It'd be positive 7. Or no, that's multiple.
No, it'd
Never
be
mind.
negative
That's
It would be -7.
negative, yeah.
Okay? Now, we had one thing that we wanted to make sure we understood. The bases have to be the same. If I'm going to put them together just like this, I can only put them together if they're all n's. If I have a squared times b to the 3rd, could I put them together? I have a times a and b times b times b. Can I count them together?
No.
No, they're different. So the bases have to be the same. And then it will work. Okay, I'm going to hand out a worksheet, and there is multiplying and dividing on this worksheet.
Okay.
We have only hit the multiplying piece. So when you go through this, ignore the back, but keep it, because we will learn how to divide exponents. But I want you only to work on the multiplying.
What does
Keep
this
your
do?
notes out so that way you know exactly how to tackle each problem. This is due on Thursday.